So, proving lines are parallel. So this is the opposite of the other one. Before we told you the lines were parallel, and what does that mean? The converse of that means that to prove something's parallel, it has to meet one of those requirements. So, the first requirement that would prove that things are parallel would be the alternating interior angles are congruent. So if 3 and 6, if 3 and 6 are congruent, that means these two lines are parallel. Okay, or if 4 and 5 is another example. If 4 and 5 are congruent, it proves that these two lines are parallel using the alternating interior angles. Alternating exterior angles also have to be congruent. An example of that would be 1 and 8, 1 and 8, or 2 and 7. That would prove that these two lines are parallel because those two angles are congruent. Another one that's congruent would be corresponding angles. I'll do a couple examples of this. So 1 and 5 are corresponding angles. If they're congruent, it proves that these two lines are parallel. 2 and 6 can be parallel. Also 3 and 7, 4 and 8. Same side interior angles are not congruent. They would have to be supplementary to prove that these two lines are parallel. So if 3 and 5 add up to 180, that would prove that they are supplementary and that the two lines are parallel. If these two add up to 180, same thing. Now, if I put an equation in one of these scenarios, you have to find out which one of these they are. If they're alternating interior angles, you have to make them equal to each other. Alternating exterior angles, you have to make them equal to each other. Corresponding angles, you have to make them equal to each other. But same side interior angles are supplementary to each other. Okay, meaning you add them together and they equal 180. Now, triangles. The two things you learned in this section is that the angles inside, if you add all of these up, whatever they write here, they have to add up to 180. So if they write equations, you have to add up those equations and equal them to 180. So all the angles inside of a triangle add up to 180 degrees. Now, 3 and 4 are a linear pair. So if I add these two together, they also have to equal 180. Now, angle 1 and angle 2, okay, if you add them up, they will equal the exterior angle they are not touching. Okay, so angle 1 plus angle 2 will equal angle 4, the exterior angle they are not touching, which means angle 4 will equal the sum of the two angles that it's not touching, called the exterior angle theorem. All right, so if I write equations here, you know they add up to 180. If I put an equation here and here, you know that they add up to each other. So you combine like terms here, and you make it equal to whatever I write in angle 4. All right, now here. So finding out if something is parallel or perpendicular on a graph, there's two different ways. You can do the counting method, rise over run. So this is going down 1, 2, 3. So down 3. Then it is going to run 1, 2. So it's running 2. Okay, so this is negative 3 over 2, rise over run. If another line has the same slope, then they are parallel. So same slope. If they have the exact opposite slope, so this slope is negative 3 over 2. If the other slope is the reciprocal and opposite, meaning 2 over 3 positive, because this is negative, this has to be positive. This is 3 over 2, this one's going to be 2 over 3. If this happens, then they are perpendicular. Okay, so one of the ways of finding slope is just counting, doing rise over run. If it goes down, it's negative. If it goes up, it's positive. And you should be going from left to right when you check the dots. Now this one. There's another method. Let's say they don't give you a graph, and you can do it this way as well. The change in y, you should know that this is x and that's y. This is x and this is y. So how does it change from one to another? So 1 to negative 2 is down 3. And then the change in x, negative 2 to 0, is up 2. Same slope because it's the same points. So it works in both methods. Okay, you could do this method or that method. And that's how you check if something's parallel or perpendicular.